So what we're going to talk about over the next 30 minutes is pretty straightforward. A little bit about what it's like to produce software at Red Hat, what kinds of things go into that, what tools we use, that sort of thing. And then Brian will talk about how we're using Sigstore internally, what we're doing when we produce software to ship to our customers. And then I'll talk very briefly about some of the things that we did in the development of a product based on Sigstore itself. So first of all, I think everybody in this room probably understands the concept of provenance. You basically want to understand every single thing that goes into the software that you're shipping. And you want to be able to trust that, and that's why we do things like sign those artifacts. But at the end of the day, what does that look like at a place like Red Hat, where we're producing software every single day? Well, some of the things that we care about, some of the things that we do in our CI/CD pipelines are pretty straightforward. We need to understand where the source code is coming from. We don't actually check for signed commits at this point, but need to understand exactly where things are coming from in terms of the source code itself, what the dependencies are, and through those dependencies we produce SBOMs that we can then check against a database of CVEs, so that when there are problems, when the CVE is issued, we can very quickly update any of our software that is affected by that, get that out to the customers. We do things like SAS checks, static application security checks. That's the kind of thing that you get with SNCC. SNCC obviously does quite a bit more than that, but that's what we use it for. And then we do things like base image checks, right? When you're building an image, you're usually starting from some base image. We need to make sure that that base image is trusted and that it doesn't have any CVEs associated with it. And then everything that we produce, the binaries, the images, the SBOMs, all of that gets signed. And then we do some enterprise policy checks on top of that. So that's kind of the big picture. Those are the kinds of things we do and look for when we're building software at Red Hat. I'll let Brian talk about sort of some of the details and how that all works.
So since 2016, we've been signing containers, and we started with a simple signing scheme for signing containers, which is based on GPG. And GPG aligns very well with our RPM signing routes, and we could reuse the same chains. The signed payload spec is actually the same one that's inside Sigstore, and it's worked very well. We typically, in the past, have had like a very restrictive software development environment. There's a very narrow, windy path that you need to navigate in order to build things in the exact right way, so that you don't run into errors and build failures and things like that. Like essentially, non-compliance with the way that we wanted to do things would result in just a failure of whatever you're trying to do. Simple signing has some downsides. It is hard to use simple signing in a disconnected environment. You need to find some way to store the signatures and be able to serve them. And imagining, take yourself back to 2016. It's hard to imagine now, but our implementation of simple signing and the storage for it significantly predates things like OCI artifacts. It supports signature store, the signature store, which is like saying signature store and Sigstore and realizing they're not the same thing. But the signature store in simple signing now supports OCI, but it didn't when we implemented it. It requires long-lived keys, and needing to select all the correct signatures you need and then lay them out in a file system properly to make it work for disconnected is super, super challenging. Sigstore offers us and our end users a suite of really nice, convenient tools. I think the user experience of cosign is really nice, and it has a lot of creature comforts like cosign tree and things like that, which I think people really appreciate. The native support for attestations and SBOMs, being able to fetch them, look at them, that is also really nice. And I think it it actually pushes users, because they see those examples, to say like, oh, cosign can like fetch an SBOM for me. Let me see if this artifact has an SBOM. Oh, it doesn't have one. I'm going to go complain now, right? So that's good, because it encourages people to like try that out and see if those things exist, and then complain when they don't exist, which helps push folks in the right direction for providing all those things. Using OCI storage by default is great because it allows us to support disconnected environments much better, because when the registry is going to be mirrored, all the signatures and attestations and the SBOMs and the things like that can just be mirrored along with the artifacts themselves. The OIDC-derived signing keys for us are actually like a bonus feature, not the main reason for us to adopt, and I'll get into that in a little while. And I feel like that sets us apart from a lot of folks, because when I hear people talk about Sigstore, it seems to be like the main attraction is these like ephemeral signing keys, and I'm going to make the case that like they should get equal billing with the long-lived keys scenario. But the killer feature, honestly, for me, for Sigstore, is the community. I've been working in this space since we first started signing containers, and I have watched as the community failed to reach consensus on how to sign containers across many vendors and iterations of schemas and the evolution of OCI and stuff like that. And now seeing some consensus finally being reached, I feel like we have an opportunity to like finally convince people that they should demand that their artifacts be signed, and they should understand what those signatures mean. It doesn't mean that everything that is signed is trustworthy, but it's a step in the right direction. I've seen just for a long time that this just wasn't happening, and now it is. So super excited to see that, and that's one of the big reasons why we are making the adjustment we're making to help continue to push that forward. So we're using cosign for signing, but we also use Podman, and Podman is growing some capabilities around at least signature verification, which I am of mixed feelings about, because I worry a bit that Podman developers may or may not do everything exactly the same as cosign does, and I don't want to see like fracturing of that, that consensus that I was just talking about. And so I think that's a thing that we need to be careful about, is making sure that as different tools grow signing and signature verification capabilities, that we ensure consistency remains intact, and that these things perform and do the things that we expect them to do, and that opinions are great, but they should be handled in the community meetings, not through like fractured tooling ecosystems. We have deployed Recor, but it's not externally available. I'll talk about that more in a minute. And we have not actually deployed Fulcio yet. A bunch of other tools we're using. We use Podman and Cryo for validating signatures at runtime, so when images are launched on like RHEL nodes or OpenShift clusters. We have a project that we started called Conflux CI, and it's kind of more like a distribution or aggregation of projects with icing. So it uses Tekton and Tekton chains for running build pipelines and producing attestations. Enterprise Contract is a project that we created to compare those detailed attestations against REGO policies, and then make decisions about whether artifacts meet policies or not and can be promoted or released. Cache 2 is a project that we have that enables us to do entirely hermetic offline builds. So essentially it's responsible for prefetching any dependencies you need, building an SBOM out of those, and then injecting those prefetched dependencies into a disconnected environment where you can build your software. Kube Archive is like a generalization of Tekton results, where we persist Kubernetes objects to a database so that we can have them for long-term storage for anything from compliance to like forensic analysis of a security incident. And then we use Trustification, which is some tools which Guac is part of that. Trustification is kind of like next to guac for us. We do use guac, and then we use all these other tools in this trustification project as well for storing and analyzing SBOMs, and also composing product SBOMs. So if you imagine like you have an SBOM for a artifact, if my product that I'm shipping has 100 artifacts in it, the government tells us that we need to give them product SBOMs. So I need to be able to synthesize all those artifact SBOMs into something that they will accept, and we use it for that as well. So we ran into some interesting challenges along the way. Some were expected, some not. I hinted this earlier, but we don't have external transparency logs yet. It's a thing that we want to do, but one thing we learned along the way is that there's really no way to keep someone from writing to your Recore instance if they can reach your Recore instance at all. And for us, this was, we didn't really want other people writing to our Recore instance, even though we wanted them to be able to search it. So we're thinking about and interested in the community's perspective on this. One thing that could be done is by adding some simple auth-z to Recore and separating out reader roles to writer roles. Another thing that we could do is keep Recore, basically situated the same way that we have it, but we could periodically do database transaction logs to some read-only database and then put an interface in front of that and let people search that way, which might be nice anyway. But yeah, you need to take precautions if you're running Recore that you don't get denial of service attacked. If you have it in your internal network, then maybe you trust people and maybe you don't. But for us, we didn't even want people to write to it at all, much less rate limit them. We could rate limit people, but we just didn't want it there. So the second thing we run into is sort of no support for multiple Recores or multiple Sigstores. It's not straightforward really at all how someone is supposed to use Sigstore when you want to be able to sign and validate against multiple instances of Sigstore, right? So maybe you want to be using images that have signatures in public good Sigstore, but you also want to use some Red Hat images which are signed with our Recore and our keys and validated against that. And then maybe some other vendor comes along and also wants to do that too. I think that Sigstore needs to figure out how to scale out by providing support for this many Sigstore kind of model. And the way I thought about this is that in the beginning with containers, there was this assumption that when you said Docker pull Alpine, you didn't need to specify what registry it was from because it was obviously Docker Hub, right? Duh. But that's not a safe assumption anymore. There's thousands of registries you could be pulling from. There's at least a dozen which are super common that you could be pulling from. And I feel like Sigstore is kind of hitting that point right now where it's always been assumed that you mean the public good Recore, but it might be time to start rethinking that assumption. FIPS. So this one's fun. So if you guys aren't familiar with FIPS, it's the Federal Information Processing Standard. And if you are at a vendor like Google or Red Hat or Microsoft or anybody else that does business with the US government, FIPS is a thing you have to learn about and deal with. So we had a bunch of really interesting conversations at Red Hat about whether when it's a machine doing the signing and not a warm-blooded human being, there's any real value to this keyless signing ephemeral stuff and OIDC, OIDC, derived keys, which is a super fascinating discussion. And we had all kinds of interesting points you're just moving, secrets to an OIDC service account and this and that and the other. And it turned out to all be totally irrelevant because FIPS says you can't use those kind of keys. FIPS basically says that you must be using non-exportable hardware security module generated keys. And so that immediately just took ephemeral keys off the table for us. So this is why we didn't deploy Fulcio as well, like I mentioned earlier. So we were using HSM-backed keys. I'll talk about architecture in a second. The other thing it requires is special builds of Go that use OpenSSL instead of Go Crypto. We deal with that across a lot of our products like OpenShift. And so we're used to that, and Lance's team has helped us out with that. And I think that's a thing that's currently being discussed upstream as well. A gray area with FIPS is, at least what I saw, was a lack of HSM integration and Recore. So there's great key store support in Cosign. There's support for PKCS11, Amazon KMS, the Azure one, HashiCorp Vault, all those. But when you get to the Recore key that's signing the signatory timestamps, it's less clear how to leverage any of those key providers. I made a judgment call that we're probably okay for FIPS because this signature is actually wrapped and signed again with the HSM backed key, but it would be more clear and less to explain, and also a better just a better disaster recovery scenario for us if we could easily use all those key providers with Recore. So where we are now, after doing a lot of this work, which took a while, Red Hat's kind of a big ship to turn around. We actually have now moved into a very permissive environment for building software. You can pretty much do anything you want in our newer software development environments, and that's because we are not making decisions based on sort of fail if you don't comply. We're making decisions based on analyzing the attestations that are produced by Tecton Chains using enterprise contract. And we have very detailed REGO policies which describe what artifacts look like which are acceptable and things that make them unacceptable. And as of today, actually today, I couldn't have timed it better, we shipped RHEL 9.5 and 10 container releases, which have for the first time ever come with Sigstore signatures and public Tecton Chains generated signed salsa provenance. Yeah, that's cool. So my intention for our architecture is actually to have two independent signing systems that we can use for business continuity purposes, where we would keep, right now we're currently using Amazon KMS with Cosign for signing, and we would add in a completely separated system where we are using our current physical HSMs, and we would ship both public keys essentially, and we would be able to use either one of those systems at any time. And then in response to a security incident on any of those planes, we would be able to just stop using them and be able to continue using the other system while we investigated what was going on. Things we have to keep working on here is we have to start producing quantum safe signatures in 2025. So this is the thing that we will be investigating, and we're already actually starting to work on, is we must start using the NIST finalized keys for producing Sigstore signatures. And if I don't know, if you deal with the federal government, again, there's NSA bulletin which says that if you're providing software to them, there's classifications, and if you want to talk about it, I'd be interested. But you should be looking at starting to produce quantum safe signatures as a opt-in capability by the end of 2025 for signing. We're going to start looking at introducing keyless signing support for Git commits, which Lance mentioned that we don't currently do yet. Making our transparency logs public, and looking at implementing Sigstore signing for Maven and PyPy. Okay, so that's a great overview of how we integrate Sigstore into our build pipelines. I mentioned at the beginning, we also have produced a product based on Sigstore. It's called Red Hat Trusted Artifact Signer. We pretty much produce everything, all of the Sigstore stack, so that's Recore, full CO, timestamp authority. We're not doing the policy controller yet, but we probably will in 2025.
We also ship all of the binaries, cosign, getsign, Recore CLI, and some other binaries as well, like enterprise contract and some stuff for dealing with tough. We're also doing some other things that have been mentioned. We've got Trusted Profile Analyzer and Trusted Application Pipelines as products. Our Sigstore implementation kind of just fits within those. So I've been working with the Sigstore project, I guess, for about 1.5 years now. And it was sort of like baptism by fire. I didn't really know about the project before I took this on. And there were a lot of challenges that I faced trying to get this thing out the door as a product. And, you know, at the base, like, it's complexity, right? And Hayden was talking about this earlier today about, you know, Recore having all these different parts. You've got Recore itself, you've got the log signer, you've got the log server, you've got to have a database for storage and a database for the search index. You have file store for the attestations. There's a lot there, so I'm really happy to see what's happening with Recore v2. I think that's going to be huge for us. The other thing that was really difficult for me to get my head around was tough. You know, the scaffolding project, I don't know if you're probably most of you are familiar with the scaffolding project in Sigstore. It was great as a way for me to learn about how to deploy all of this stuff. But when I started, I just deployed, you know, the scaffolding tough repo, not realizing that every time you restart the pod, it just overwrites or it used to just overwrite the tough repository. So there were some changes that we contributed upstream for that, and we hope to contribute more changes in the coming year upstream towards simplifying that, making it have some sane defaults. We also encountered the format changes with trustedroot.json happening as we've been implementing this stuff. It was a lot to get my head around, and I think we've done a pretty good job. We just released today, TAS or Sigstore on RHEL using Ansible playbooks, and it also runs on OpenShift. I think it runs on bare Kubernetes, but it's not really our target. So it runs on OpenShift as well, using the operator framework. So now installation is kind of point and click simple, as long as you're not bringing your own keys and stuff like that. There's a little more configuration that you have to do if you're doing that. But for the purposes of demo and trying things out, it's pretty straightforward. So the things we're looking at in the coming year are model signing and attestations. Obviously, there's some ongoing work upstream, which we just saw. And I mentioned earlier, we'll probably be pulling in the policy controller on Kubernetes. And that's kind of where we are today. And that ends the talk. I guess we can open it up for questions.
There was a bit where you said Podman and cosign kind of interrupt okay. Is Podman just verifying signatures on its own without depending on any of the Sigstore libraries, or?
Yeah, take this with a grain of salt because I'm a product manager. But yeah, I believe that I'm trying to think of the containers project that they have. There's the Podman project is in this. I can show it to you where it is. I have a GitHub, but yeah, I'm pretty sure that they have essentially rewritten the validation code for Sigstore signatures in Podman.
Great presentation. CPython famously has recently stopped publishing PGP signatures and is only publishing Sigstore bundles. I know that Red Hat is a large organization, but do you have any thoughts on RPM support for understanding Sigstore bundles?
Sorry, RPM support for?
Sigstore bundles.
Yeah, so we have talked about this a lot. There's a really lengthy paper that I think that was written. I'd have to find out if I can share it, but I would ask the author if I can share it, and if they say that I can, I'd be happy to share it with you guys. A lot of work has been put into investigating potentially replacing the attached GPG signatures for RPMs with Sigstore. We have there's a couple of challenges. One is just that the GPG thing is so embedded in RPM, and would take a significant effort to undo that. We're also wrestling right now with other changes, including the post-quantum changes. So we're actually currently starting to look into embedding multiple attached GPG signatures. Some will be the classic signatures and some will be the PQ signatures. And moving to detached signatures for RPM would be really interesting, really strange, for that ecosystem. We are probably going to start producing detached Sigstore signatures for RPMs though, which would be our way of providing the opt-in PQ signing that we need for 2025. So the other thing that factors in for me is that when I look at our long support life cycles for RPMs, if we changed over to Sigstore from GPG right now, I would still need to produce GPG signatures until 2034. And then I start trying to figure out whether this Sigstore will still be the thing 10 years from now, and it's so we wrestle with some of that too. We're going to be producing GPG and Sigstore signatures for containers for at least 7 years, I think, is what I think right now. So just to provide compatibility for long tail releases.
I'd be curious to hear a little bit more about your requirements for post-quantum. Are you looking at the signing of the artifacts themselves, or post-quantum signing all the way up the stack from TUF all the way to the signed artifacts?
I think it's for the artifacts themselves. The requirements are not very detailed, and I can point you to them. But the requirement is that for any artifacts that are delivered as part of a product to the U.S. government, in 2025, they expect to have some opt-in method for doing quantum safe artifact signature validation. Doesn't have to be the default. That's the opt-in part, right? So.